Let's take a look at problem number 2. It says y is equal to the cube root of 2x minus 1, and y is equal to 0, and x is equal to 8. And it says find the volume of the solid formed by revolving the region bounded by the graph of this about the x-axis using the disk method. Well, let's first get the picture of what we're looking at. So I'll go to my graphing calculator. Excuse me. I press y equals, press clear. It's a cube root. So I go into my math. I'm going to choose my fourth one. So I do 4. And it's 2x minus 1. So I do 2x minus 1. Close parentheses. You don't have to have closing parentheses at the end and do graph. Now it looks like this. Now definitely the ending, or upper limit, is 8. The question is what the lower limit is. We have to find the intersection, what our graph looks like is something like that. And here's 8, x equals 8, so that's bounded by that. The question is, what's this starting value right here? Now that's the intersection of this cube root, so it's a point of intersection, of the cube root and y is equal to 0. That's what this line is right here, the x-axis. So set that equal to 0. Well, if we got a radical equation, we take both sides to a power equal to the index. This is 3, so we'll take both sides to the third power. And we get 2x minus 1 is equal to 0. Take the negative 1 over, becomes a positive 1, and then we get 1/2. So that tells us the beginning one there. Now our formula for the disk method about the x-axis is our volume is equal to pi a to b, and then r of x squared dx. And for a very simple problem like this, we don't have to worry about 2 graphs, so we're just dealing with 1 because it bounds the x-axis here. So we'll have pi, and then a to b, so we got 1/2 to 8. And I'm going to take the r of x, which is my cube root of 2x minus 1, and square it, and then dx. Okay. So 1/2 and 8. Now we rewrite this as 2x minus 1 to the 1/3 power. Remember, we don't like radicals for the most part when we're dealing with the integrals, so we rewrite it. And we're raising 1/3 to the second power. So that's going to become 2x minus 1 to the 2/3 power dx. Now I'm going to do a u substitution here, and we're going to let u equal to what's inside of parentheses. You got parentheses to a power, that's always one to try. Then du, the derivative of that would be 2 dx. So I need a 2 inside. Well, I'll offset it with a 1/2 out in front, like that. Then we got our 2 inside dx. And now I can do my substitution. Now these values I'm going to put as x equals 1/2, and I'll put as x equals 8. We don't want to forget those are actually x values. 2x minus 1 gets replaced by u, so this is u to the 2/3 power, and 2 dx gets replaced by du. Well, then we want to add 1 to our power, divide by our new power. If I add 1 to this, that gives me 5/3. So we're going to have 3/5 u to the 5/3, 1/2, and 8. Oops. Meant for those still be x values. Now you could do a switch where instead of these being x values, you plug it into your u substitution up above and change these to u values, but that's up to you. Now I'm going to take that 3/5 out in front so I don't have to worry about it. And we got u to the 5/3 left inside, and u we said was 2x minus 1. So let's put that back in. And 5/3. And this is now back to 1/2 and 8. Well, that gives us 3 pi over 10. And plug in my values here. And we got 2 times 8 minus 1 to the 5/3 power minus 2 times 1/2 minus 1 to the 5/3 power. Well, 2 times 8 is 16 minus 1 is 15, so we got 15 to the 5/3 power. And here we got 2 times 1/2, which is 1. 1 minus 1 is 0. 0 to any power drops away, so that's gone. So I'm going to have 3 pi, and then 15 to the 5/3 power over 10. And we don't want to simplify it any more than that. We're happy with that answer.